Hello! MPU4 power supply. While I was up getting a video of that Hyper Viper, I got asked if I could sort the power supply on another game they've got, which I will make a video of at some point if I get it going for them. It is called Luxor. Now, it doesn't take a genius to work out something's gone seriously wrong with that capacitor there. That one there's exploded internally. You see the top of it? Very, very crunchy. So, I'll show you what this is doing at the minute. I thought at first it would be the 12 volt line that was bad, but no. The 12 volt's okay, as far as I can see. But I'll show you what I'm getting on the lamp line. So if I just put you down here for a second, you get to see the bottom of my table. And plug it in. Right. And it is that pin there. We should be getting 34 to 36 volts out of that. We're getting 29. But here's the kicker. See if I go to AC. Now we're on the same pin. See? We're getting 14 volts AC across, and more than half of the 34 volts is coming through as AC. Now, I think the MPU4 board can sort of cope with that, but it'll be causing tremendous amounts of interference. Now, what's happening with this Luxor game at the minute is, well, basically it's not booting up, it's just constantly rebooting. It's just in a boot loop. It gets as far as initialize. I think the screen says init lux something, and it just keeps going like that, and occasionally rails bump. So I've connected up to the scope now. I've got the scope running. If I just go here, now I've got that on the scope. I've got that on a times 10. Look at the waveform. That's meant to be a flat line. That's meant to be a smooth waveform. That capacitor is completely and utterly dead. It's just allowing all the ripple to pass. So no wonder the game's not working. Now I've tested the 12 volt. The 12 volt is absolutely spot on. We're actually getting 17 volt out of this. The capacitor's banging. With this one, well, it's just an open gate. It's just a pass through. So we've got to see if we can get something to repair that. So, right, so I was going to swipe a couple of capacitors out here, but because the caps in that are 4 tag, they're 4 pin. You get special types capacitors for heavy duty PCB mounting. They don't have 2 legs, they've got 4. It's in a kind of, some of them you get 5 or 6. It's either in a star shape or a square shape formation. You get 2 positives and 2 negatives. Sometimes you get 3 positives and 1 negative, sometimes 4 positives and 1 negative. But the whole point is, for reinforcement, is to make sure they don't come off. Now that capacitor would be ideal to take. It's an exact match for what's in there already, but it's absolutely huge. But what I do have is this, I believe this is a bad relay. It's a Mega power supply board, and that is a perfect rated capacitor there. I'm not so sure about that 16 volt one. That's perfect rating there. 70 volt 4700, but it's only a 2 pin. So I'm going to have to figure out, but I believe this was donated to me. So yeah, I think I got this off Mr. Troll. So I'll shout out to Mr. Troll now. Thank you very much for this. Yeah, it was for a project I'm doing. So thanks for this, and I promise I will put a replacement capacitor in, but in the meantime, to get this one going, I'm going to borrow this and see if I can figure out a way to mount it to there. Right, so to get these open, 2 screws there already, a couple have been missing since I got it. There was no screws for the lid, that just come off. 2 screws there, and then I believe that slides down. Yeah, so there we go. That capacitor's destroyed. It's blown up, it's blown wide open at the top. I don't know if you can see that. Yeah, it's blown open at the top. That capacitor's gone. So we'll change this out. Probably replace that 1000 at 16 there as well. So we need to get this board off of here. To do that, I don't know if you can see that very clearly, but the rectifiers are mounted to the back of the PCB and then they're screwed into the board. So we need to do two things here. One, we need to get these screws out here, and then two, oh lovely, they're screwed in as well. Need discharge capacitors first, but that's okay. So we'll get these screws out here. We'll lift this PCB up and then we'll see if we can desolder this, and probably have to get the desolder station out to this, because this, you can see the pin, what I was talking about there, the 4 pins. You can see that's overheated, that's melted the solder on that one as well. That capacitor blew big time. It must have been a funny smell in the arcade when that went. They kind of give off a fishy smell. It's like a rotten fish smell they give off when they blow out. It's not very pleasant at all. I've smelt one of these go before. I've seen it smoking. It's not fun. Yeah, but it looks like it melted the solder there. So we'll get this off. I think I can. If I just compare the. And there's the pin pitch on these 2-pin ones. I mean, it's smaller, but it's exactly the same rating. It's actually slightly better rating. Yeah, they're both 85-degree capacitors. They're both plus minus 10%. Yeah. So yeah, I think that'll fit. The pin pitch looks about the same. Hold on, coffee coming. Just there. Okay. Coffee has been installed onto the bench. As you all know from previous videos, this is a house, so things happen in the background when I'm doing these videos. Yeah, I can even see underneath that one, it's blowing out at the bottom as well. Right, so 2 screws, get this off, get that capacitor out of there. Just a side note, somebody's been in here before, because that screw is just coming straight out. The board isn't even tight. I think that won't help because of thermal paste on the back of them, you see. So I think I'll add some thermal paste when I reinstall this, and I'll screw these down as tight as I can. See, that one just come right out there. See the other one? Yeah, I could do it. Yeah, one hand. This board's been out before. That probably won't have helped with the heat dissipation, so that's probably contributed a little bit to that capacitor blowing up. Maybe not, but yeah, need to change it anyway. Take that nut and bolt there out the side as well, and you can swing the whole back plate off and get to where we need to be. Right, so the back plate's off. You can see the remnants of the thermal paste there. I will clean that up with some IPA and add some new thermal paste. I'll add a wee dab of thermal paste to each of these as well. I've got some nice stuff. It's built for computer processors, but it's nice and it's self-adhesive as well. So once these go on, they'll stick on. Right. Next job's to get this exploded capacitor off. We'll just check on this pin pitch again. And I think that's going to be okay. So you can see here, this is our target here. You can see here it's got 4 posts and this one's got 2. But the one down there and that Scorpion 2 is enormous, and it's not going to fit in there with that. You can just see it in there, that mains fuse holder in the way. So I've got 2 options there. I can either move that fuse holder and put it elsewhere in the cabinet, or I can try a smaller capacitor. So I think I'll try a smaller capacitor. So what I need to do is identify the positive and negative lines here. Now, I'm not too bothered about discharging it. It has no charge in it. It's dead. It's completely dead. So I should be able to just take the solder off, pop this out, and then I'll use a Sharpie to mark the 34 volt positive. I mean, I can see them there. that's the 34 volt supply there, and the returns up here on pin 2 and 3, so you can see that coming down there. So what I need to do is put the capacitor maybe across these 2 pins here, or these 2 pins here, and then so the negative will go to that side and the positive will go to this side, but I'll trace it all out. I'll check the circuit diagram and we'll see how we get on. So yeah, let's get to it. I've just noticed that this board is all attached to the transformer with tag terminals. So what I've done is I've got a Sharpie pen and I've labelled them 1, 2, 3, 4 and 5 and then photographed it so that I can remove this and work this flat on the bench. That way when it comes to reassembling it, I just refer back to my photograph and I don't have to buzz or trace anything out. Just to note, these are super tight, so to avoid breaking them, just gently pinch them here. I don't know if I can do this one-handed, but no, I can't. Well, maybe I can. Hold on, if I can get a grip it. No, I can't do it one-handed, but the idea is you gently work these off with a pair of pliers and they pop up. I can't get it off. I'm actually breaking the solder on there rather than pulling this off, so yeah, I will just do it in situ. Right, just in case you want to know how to discharge a capacitor, pair of insulated pliers across the terminals. Make sure power's off when you do this. Tap it across a pair of pliers. Be careful when you're doing it, make sure you're insulated. No charge across that at all. Just noticed as well with having a look around that somebody's definitely been in here before, but we've got a bit of terminal block there. So I wonder if this board was changed at one point. Right. I don't know if I'll be able to do this with just this little 15 watt. Oh yeah. Solder seems to be melting really easily. Well, let's just reflow that a bit. Just dab in and out of it. Yeah. I need a bit of help with that one. Yeah, let's see if I can get this off. There we go, it's out. And it's leaked everywhere. It's leaked down the bottom on the base as well. And yeah, it's blowing wide open on the top. It gone. Wonder what capacitance it's got left, if any. Let's see. I'm going to measure the pins and see what it's got. There's the answer, completely open. Yep, totally open. It's doing absolutely nothing. Right, and there's the PCB. Looks a wee bit ugly, but we'll give it a clean up with some IPA. And we'll clean this flux off, clean the pads off. While I'm looking at it, I don't see any dry joints anywhere. There's might be a little short there, I don't know. No, it looks alright. Could be a little short there. Right there. Yeah. Let's see if that comes off. Yeah, just brushes off. Right, okay. Looking around it, I don't see any. I see lots of flux from previous reflows, but it's generally alright. Somebody's definitely been in this before. This capacitor's been changed. All this flux, I don't think they've left it on for the factory. And yeah. Next job is to get him off of, yeah, see, the focus is gone. Hold on. Yeah, next job is to get that one off and work out how it mounts onto here. Right, got the spare off. I'll just check the capacitance on that one. That's better. But 4300 is 4700 plus minus 20. Yeah, that's alright. Right, so you can see I've marked it with a Sharpie. I'm 34 volt line comes away down here for pin 13 and the return line's up at pin 2. That's so you can't short them together by accident. So if you trace them on the back of the board, here's pin 2 and 3 here. That's gone to the negative, and the positive comes all the way around here and goes down to pin 13. So the capacitor goes this way around. So it will be that orientation on the board. There we go. It's on there. Took a lot of heat to get that to stick, but it's on. So we'll give it a clean up now and then we'll start reassembling this. There we go. I've cleaned all the old. God's sake, this thing's dirty. We'll clean it up. It needs a good clean with it needs a good cleaning over it with IPA and tissue paper, but we'll clean it up. Cleaned all the old heatsink paste off the top of those. You can still see the remnants of it on the board, but we'll clean that off as well. I've given this a good scrub as well, and we'll put some brand new thermal paste on here. And we'll start reassembling. There we go, all cleaned up. We'll just wait for this alcohol to dry and then, maybe a bit more cleaning in there. Wait for the alcohol to dry and then we'll put new thermal paste on. There we go. Got the screws back in tight and our thermal paste has spread, which is exactly what we wanted. So now we can get on with the black art of testing. Just got to put all the screws back into it now. They're not to go down there. Small screw there, small screw there, small screw there, and then screws for the lid. There we go, all assembled. So there's just a lid to go on. There's one screw left. We need to take a screw back out of there and put one screw in here, then that just goes on top like so. You find a lot of these power supplies back these days. This is missing, which is not very advisable because that whole point of this is to stop coins and things falling down into there and causing mischief. So let's see what she does. Right, left a wee while where I got some tea. Let's see how we get on now. So we go back on the old pin 13 here. Yeah, I think you can see a bit of a difference now. Now that's off load. On load on the machine it'd be about 34 volts. So let's go to AC. See what AC is coming out of it now. Nothing. Not a sausage. Alright. And we can prove that by firing up the old scope. Yeah, that. Right. Take this over here. Where's my scope probe? I'll just do this real quick. Right. Yeah, look at the difference. Hold on, we're not saying here. I'd be mad. Yeah, I've got the probes, the scope probe set to times 10, so yeah, 4.5 volts, so 45 volt coming out. Yeah, so that's a fix. So what I plan to do with it now is I'll probably run it in my machine for a while. I've got a 86 MPU4 through there. But that's doing the job. Alright, I'll get a mess of the table from all the various things I'm doing. Anybody want a paperweight for your desk? Dead Z80. Powers up fine, but several of the pins do absolutely sod all. So something's open internally. Yeah. Time to clean up the kitchen, I think. Alright, more to follow.